In this video, we'll go over limit as x approaches infinity of x times sine of 1 over x. Notice that if you'll try to solve this limit, you get indeterminate form. Just a reminder, indeterminate form means when we get 0 over 0, infinity over infinity. You have two ways you can solve this limit. First one is using the squeeze theorem, and we're not doing that in this video. If you're interested in that solution, I'll leave a link to that video in the comments. Second way is using L'Hopital's rule, and that's exactly what we're going to do. Let's start with a basic introduction of when we should use L'Hopital's rule. Basically, whenever you get indeterminate form when trying to solve a limit, you can take the derivative of numerator and denominator and try to solve for your limit again. Notice that it has to be in indeterminate form. If you don't have indeterminate form, you can't use L'Hopital's rule. Otherwise, you're going to get a wrong answer. We're going to take the derivative of numerator and denominator separately. It's really important to treat them like two separate functions. Notice that we're not using quotient rule to take the derivative. Instead, you're taking two derivatives separately. First of all, let's rewrite our function just so that we have numerator and denominator. Now, what is the limit of sine? That's going to be just cosine, right? But notice that we have x raised to the negative 1. So you have to take the derivative of the inside function. This is the case when we'll apply chain rule to our limit. And now, when trying to solve for derivative of the denominator, in this case, you can just take a look at the solution we got in our numerator, because derivative of the denominator is the same as the derivative that we found in the chain rule, so you don't even have to think about it. Think smarter, not harder. So whenever you get a chance to skip a step, do it. So now we can just cancel this out, and we're left with limit as x approaches infinity of cosine of 1 over x. So now you can try to visualize this function. What happens to cosine of 1 over x as x value increases? Basically, you'll have something like that. Your function is going to get more and more positive eventually, and over here it's going to oscillate between 1 and negative 1, something like that. So your value is going to get closer and closer to 1, so the answer is just going to be 1. Also, you can think about it in terms of substitution. You can say that it's the same as limit as t approaches 0 of cosine of t. That's, again, getting closer to the squeeze theorem. You can think about it this way if that makes it easier. Either way would work. You would get the same answer of just 1. So thank you for watching this video. I hope you found it helpful. Don't forget to leave a comment, subscribe to my channel. We'll see you in the next video.